So, today we are going to talk about the next chapter, that is 1.2 motion. The first topic that we should be covering right here is speed and its different units. Now, first thing, what exactly is speed? If we are talking about the numerical formula, then it is the distance traveled by the time taken. And the units are also shown here. The units for distance are miles, kilometers, meters, and then feet, and then centimeters. And for time, they are as they're written here. And then for speed, they are written over here. That if it's miles for distance and time for hours, then the speed unit will be miles per hour because because of this formula. Now, what exactly do we understand by speed? So, we see that speed is when we talk about speed in our daily life, right? So, we say that something is traveling fast, or that a snail was going too slow, or that the runner was running fast. What exactly do we mean by saying fast or slow when we are referring to speed? When I say fast, or when people say fast, then that means that they're referring that that person covered more distance in less time. And when they're saying slow, it means that they are taking more time to cover some distance. So basically, speed the is basically the distance traveled per time taken. That how much distance in whatever the unit we are measuring in does a body or an object travel in some specific amount of time, or in a second, or in a unit time that we are considering, whatever unit we're considering. um, for the course of this syllabus, however, we will stick to meters per second mostly, but you should also be aware of how to convert the meters into hours, and the seconds into hours. The hours into seconds, and or if the distance is given in kilometers, then how to convert the kilometers into meters, or to basically turn into SI units, which is for most of the time for your own convenience. Moving forward, okay, the next concept is basically what is a scalar and vector quantity, and this is something that we'll be discussing very quantitatively and qualitatively in our next chapters, and even in this chapter. So basically, scalar unit is any quantity that is fully described by its magnitude only. That when we present a number, or when we give a number, then we are that's all we need to describe that quantity. We don't need any other information to describe it. It is described by just a single number. Some examples of scalar quantities include speed, volume, mass, and time. So whenever we are referring to speed, or let's just say in our daily life, the biggest example is that of a speedometer, right? When we are traveling in the car, we see that there is a speedometer, and it gives us the speed, that the number, that how much kilometer per hour or miles per hour is the car going. So that's a number, and that's all we need to get the speed of the car. Then this volume is a three-dimensional quantity, which describes that we have discussed in the previous lecture, which means that what is the amount of the matter that is in a body. um, and then mass is mass of how the mass of something, the weight of something. And let's just not confuse mass with weight, but the mass of an object that we would observe when we are buying something, or um, when we are buying fruits from a fruit vendor. So mass is also a scalar number. Basically, I'm just saying that these are the quantities that are and that, like, for them we just need a number, and they are completely defined. For vector, however, it is a quantity that has both magnitude and a direction. That for to define a vector completely, we need a direction as well as a number. For example, the examples are those of force. Like when I say that I applied force, I am applying it in some some direction, some specific direction. Like let's just say if I open the door right now, I am applying a magnitude of force, but what direction am I pulling the door, or what direction am I pushing the door, right? So push and pull, they are in different direction. So for force, to define a force fully, we do need a magnitude as well as the direction of the force. Similar is the case with velocity, acceleration, and momentum. Moving forward, so um, the difference between speed and velocity. Well, you must have seen this by now that the speed is given over here under the scalar terms. However, velocity is given under the vector terms. So the basic difference is, from what we can see, is that velocity is a vector quantity. However, speed is a scalar quantity. Now, how exactly is that different, and how, like, what is the basically physical difference when we are talking about velocity and speed? So, velocity can be defined as the rate at which an object changes position in a certain direction. Now, this is very important for you to understand that that velocity is defined as the rate. So, the part of where it says that it is the rate is similar as that of the speed that we earlier discussed, the time taken, right? It is talking about the time taken at which an object changes its position in a certain direction. Now, this word, in a certain direction, is very important. That, let's just say, wait, let me take out the pen thing. So, if an object is going from here, let's just say this is point A, to point over here at point B. If I'm defining the speed of the object, I'll just measure this distance, which let's just say it's 5 meters or something else. Let's just go with 5 meters. And it takes the body 2.5 seconds to travel from A to B. If someone asks me to give them the speed of the object, I can just divide 5 by 2.5 and it will give me 2, and I'll say that the speed of the object was 2 meters per second. However, if velocity is asked, then I should show sorry, I should. There isn't a lot of space, so I'm drawing it over here at the top. That the direction of velocity is from A to B, or towards the right, and its magnitude is 2 meters per second. So I am specifying a certain direction, and that's how we define velocity fully. Okay. The rate at which an object covers a certain distance is known as speed. So over here, we're talking about distance. We're not talking about changing positions in different directions. When we're talking about speed, we're just saying that all we need is the magnitude of the between the 2 points. So velocity is a vector quantity. However, speed is a scalar quantity. The velocity of an object changes with the change in direction. Therefore, the object must uh, follow one direction. The average speed will continue to count even if the object changes direction. So this is pretty simple, that the average speed will stay the same. Like if we just count the distance that it has traveled and we divide it by the time taken, whether the object, let's just say the one that we were considering, goes from B to it goes to C over here, and then it goes from D to over here, and then it comes back to A, right? Then it comes back to A. So it's basically going for like this, A to B, and then B to C, and then C to D, and then it is going from D to A, right? So if this is the case and we're asked to find out the speed of an object, then I'll just measure the distance between A to B and then add in the distance of B to C, which let's just say is also 5 meters, and from C to D, which let's just say is also 5 meters, and then from D to A, which is also 5 meters. So when I'm asked about um, when I'm asked to find out the average speed or the speed of the object, then I can simply say that it is the speed of the object is 5 plus 5 plus 5 plus 5, 20 divided by 2.5, and that it was 8, I guess 8. meters per second. Wait, let me see. 20 divided by 2.5, yes, 8 meters per second. So that is the speed. However, now this is very tricky, and this is where the main concept lies, and I want you to listen to it very seriously. So the thing is, I'm just gonna change the color and change the pen to a highlighter, I guess. Okay, so now we are talking about the velocity, right? Velocity, if you read the definition again, it is defined as the rate at which an object changes its position in a certain direction. Now, in this case, ask yourself a question. What you have to identify is the final change in position. Is there a final change in position? Well, in this case, there isn't because the object returned back to its original place, right? So, the velocity of the object of the overall this journey, and when we're talking about it, would be zero, right? Because it comes back to its original position and the direction is not changed and the position is same. So velocity is basically, and let's just say if it did not come back to um, if it did not come back to the original position, if it at the last point was at d, then the velocity would have been 15 divided by 2.5. Okay, so this is like the difference between velocity and speed, and you need to also know that this is also an example where we see that in most cases, especially when the starting point is not equal to the ending point, the magnitude of speed and velocity is the same, but however, in some cases, it is not. So moving forward, it is a very important point, so just keep that in mind. Okay, the next concept that we are talking about now is acceleration. We talked about it when we were talking about the examples of um, when we were talking about the examples of quantities that are vectors. So acceleration is also a vector quantity that is defined as the rate at which an object changes its velocity. So if you think about it, it's basically a change in velocity. So let's just write, I'll put a delta because delta represents change, delta v divided by time. So this is basically acceleration. Okay, this is very what is the difference between okay laser. Okay, so d sorry. Okay, so basically now we know that acceleration is the rate at which an object changes its velocity. Initially we were like when we were talking about velocity, let's just say it had a similar definition, but the difference was that we were talking about changing its position or changing its displacement, right? So in this case, however, it's like the next form and it's about changing velocity. An object is accelerating if it's changing its velocity, right? If any object is changing its velocity, it is accelerating. Acceleration rate at which velocity changes with time in terms of both speed and direction. Obviously, we are including the direction because it is a vector quantity. A point or an object moving in a straight line is accelerated if it speeds up. If it speeds up or slows down. If an object is over here and then over here, like this is its starting point, it was A over here and this is B. And let's just say its velocity at A is 2 meters per second. Meters per second. This is an index that shows per second, and let's just say over here it becomes 5 meters per second, right? So going from A to B, if we see that there is definitely an increase in velocity, so I say that the object is accelerating, is indeed accelerating. However, when the object is, let's just say, moving from B to A, it is again accelerating. There is a concept that will be introduced in the later slides that when an object is like generally or conventionally, when we talk about an object speeding up, we say that it is accelerating. And when we say that it is slowing down or the speed is decreasing, then we say that the object is that the object is decelerating. Motion on a circle is accelerated even if the speed is constant, because the direction is continually changing. For all the kinds of motion, both effects contribute the acceleration. So this important this oh, wait, let me show you this point over here that says that rate at which velocity changes with time in terms of both speed and direction. This is very important because you need to know that accelerations happen when even one of these things is changing. Let it be speed or let it be direction. So in the case when an object is, let's take an example that it's okay, it shouldn't, okay, and let's just draw it over here. If like this is a circle and the object that I have to make from another ink in, I'm sorry. This is an object and it is going around this circle, this path that I've made. Not exactly, but you get it. Let's just assume that this is a circle and it was moving like this direction and like this, right? So the thing is, this object is moving in a circle, but I say that its velocity, that its speed remains 2 meters per second. Like I'm in a car and I'm driving this car and I keep moving in a circle, and um, my what do you say? And the magnitude of the speed of my car or the speedometer is showing that my car is going at 2 meters per second, right? Now, if you think about it, the magnitude is same. So why do we still say that the object is accelerating or that my car is accelerating? The point is that it's not changing its speed, it's not changing the magnitude of its velocity, however, it is changing its direction. So if it's changing its direction, it's changing velocity. The velocity is changed, so we say that it indeed is accelerating. Okay, moving forward, these are the basic formulas of average speed, which is a scalar quantity, which means the distance moved divided by the total time taken. And then velocity, which is the distance moved in a stated direction, or in other way, this can also be written as displacement. Well, it might take some time writing displacement over here, but you understand what I'm saying, right? So displacement, okay, is which in a certain direction, which also equals displacement or the final displacement. Acceleration, and then the last formula is that of acceleration, which means that when we have this quantity at one point and then at another point, then if we find the change of those two quantities and then we divide it by the time taken, then that gives us in turn the acceleration. Okay, so moving forward. Now, this is a very important concept and it is called as distance time graphs. Now, what exactly are distance time graphs? So first of all, it is a graph, right? And why exactly do we need distance time graph? Well, distance time graph gives us an image of the motion of the object. We need graphs to interpret the motion of an object in a better way, because if we have just the data of it, or like a table with some numerical figures over it, that at this second the speed was this, or that it had traveled this much, then that's not exactly giving us the entire data about, or the entire idea about the motion of the object. Distance is plotted at the y-axis, as you've already probably made a lot of graphs in your previous classes. Basically, even in this one, we are going to take distance on the y-axis and the time on the x-axis on the independent quantity scale axis. Sorry. The slope or the gradient of this graph would represent velocity. Now, it's all right if we do not understand what I'm talking about right now. Let's move forward, look at a distance time graph, and do not get scared by this diagram. I'm going to explain it to you completely. Okay, moving forward. So, distance time graph. As I said, the distance is in the y-axis and the time is in the x-axis. The time is in seconds, distance in meters. This is already in its SI units. Okay, first of all, we are going to talk about the green line. I see a green line. This is a straight line. It has no curves. It's just a straight line, right? It's a straight line. A straight line shows that the object the object is moving with steady speed, with uniform speed, that its speed is not changing, is not increasing, or is not decreasing, right? So it's a straight line, and now how do I know that its speed is not changing? Well, the total area that is covered by, or the total time taken for this journey of the green line was 5 seconds. Let's just um, examine this graph for some seconds. Here we go. I'll put it 5 over here. So we know that it was of 5 seconds. And I'm sorry. My internet just went away. So resuming from there, we're talking about the green line, right? So in these 5 seconds, basically, let's just take I want to find the speed at 2 seconds, right? Because I want to know if its speed or if its velocity remains constant. Now, what is the distance traveled at 2 seconds? If I project from here, I can see that it was 40. So 40 divided by 2, that gives me 20. So I know that at time at time 2 seconds, the velocity or the speed was exactly, the magnitude was basically 20 meters per second. Let's just say if I take it at 4, I come over here and I say that it is 80. 80 divided by 4 is again 20, and similarly at 500 divided by 5 is 20. So that's just the mathematical way to prove what I'm saying. But how, what's the main reason behind it? Well, the reason behind it is that the speed is basically the gradient of this graph, right? The gradient of this graph, the gradient which is basically the rise over run, the difference in the y quantities divided by the x quantities, the change in y quantity divided by the change in x quantity. So if you look at it, the gradient of a straight line is always constant. It is always the same number, which in this case happens to be 20. So this tells us that, and the gradient is basically what? Y, change in y divided by change in x. And what quantity does y show? Y is the distance and x is the time. So y divided by x is distance divided by time. What is distance divided by time? It is speed. So that tells us that speed is basically given by the gradient of the distance time graph. Now we're talking about the now how do I know if this steady speed that we have, like now we know that the steady speed is when the graph is a straight line on a distance time graph. So for that, when the gradient is more, it means that the speed is more, and that means that the object is traveling faster. Now, what does it mean by higher gradient when we look at the graph? the lines which are more steeper and which are more towards the y-axis are the steeper lines or have higher gradient, because if you look at this and we are examining this green line and this blue line, then I can see that this green line is more towards the y-axis than this blue line is. Let's just say I take this point 40, and I see that the distance from 40 to this green line is approximately 2, whereas if I see it at for the blue line, it's 5 seconds. That definitely means that the green line is closer to the y-axis, and when it's closer to the y-axis, it tells us that it has more gradient and it's at higher speed. Now, we have talked about straight inclined lines that are at an angle in the graph. What about lines that are horizontal or vertical? Well, before talking about the horizontal line, I want you to know that vertical line basically means that that the change in x value is 0, right? And what is the x value? X value is time. And it is impossible for any object to travel any distance in no time. And even if we talk about light, that is impossible. It does take very, very, very less nanoseconds, but it's still some amount of time. So if we talk about physically an object traveling even very small um, distance in no time, that is physically impossible. So a vertical line on a distance time graph or even on speed time graph that we're going to discuss after this is impossible. So talking about horizontal line basically means that time is going on. The x quantity is going on. However, there is no change in the y quantity, which completely makes sense when an object is at halt or it is stopped. So the horizontal line, which is given over here in the blue on the blue graph, and if you look closely, it says stop, this one over here. So that is exactly talking about what I am saying, that the blue line represents that this this horizontal line represents that the object is stopped. Okay, now we are talking about this phase of the blue line from 9 seconds, from 9 seconds, yes, from 9 seconds to 12 seconds. Now, I do see that when it is at 9 seconds, the distance is at 40. And when it is at 12 seconds, the distance is at 0. Well, the distance that it represents over here is from a specific point, like let's just say from point A to how far it is going away from point A. So when its distance from point A is 0 over here at 12 seconds, that means that the object has came back to its original place, and it is like, it has come back to its original place. Hence why is the distance shown on the graph is 0. So this basically means that the speed is steady, that the speed is still steady, that the distance is still covered, but it was covered in the opposite direction and it was returning to the start point. So that was all about the blue line. Now talking about the red line. The red line shows a journey starting 2 seconds later than the other two, with an initial acceleration, then a deceleration, and then a stop. Okay, now before talking about the red line, I want you to remind you and to remember that the gradient of distance time graph represents speed. Okay, and if the line is steeper, then it means that the speed is higher, and when it is more towards the plateau side, or more towards the flat horizontal line, then it means the speed is less because it is more closer towards the towards the x-axis than the y-axis, and it is far away from the y-axis. So initially, on the red line, I see that from 0 to 2 there is no distance covered. Like I cannot see any line over here, which means that it is at stop, like it's not moving, and there's no distance covered. So at 2 seconds, however, there is a line, and it's very, very, very flat and plateau-like. So from this plateau-like line, it rises up and turns into this mountainous hill thing. So that definitely tells us that this plateau is turning into a steep slope. What that tells us that its gradient is changing and its gradient is increasing. And what does gradient represent? Gradient represents the speed. So this tells us that the speed is actually increasing. Now it increases, 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 and then at this point, after this point, I see that there isn't any substantial increase, or I don't see that the gradient is increasing or turning steeper. However, I see something opposite, that the gradient has, however, changing, and it's going towards the plateau side in again, like it's going towards the horizontal phase again. So that means that from the green part, it's basically slowing down. The gradient is decreasing, which means that the speed is decreasing, and if the speed is decreasing, it means that it is slowing down. So this is all about and that the speed is slowing down. Well, this is all you need to understand from the distance time graphs, and this is all about this graph. It did look very, very intimidating and very difficult, but it's actually very simple. And if you look at it and if you understand the gradient concept easily and you take your time, then it's very easy to understand this concept.